So we're about to commence a new year. We're about to go into a new 2024. It will be good for you to have some sort of roadmap, some sort of goals going into the year, right? This is a brand new year. You need to have goals, and what a way to conclude the year, by finishing the boot camp today. So please, I just want to admonish everybody, please make it a date, like start planning as from 2024. If you want to take 1 month per AWS course, please, you need to start now. You need to prepare now. So 2024 is not a time for preparation. Now is the time for you to be able to prepare, reflect what you've done so far, which of course, part of the highlights is attending a boot camp like DevOps the Service Nigeria, and plan where are those places where you're having challenges. Plan, write them down, right, and then follow suit. I can bet you, if you're able to do that within within the first 6 months in 2024, by July, right, I'm sure you should be standing tall, in interviews and what have you. It's even possible to even be before then. But I'm just begging us, please, let's not just throw away all that we've learned. This is the right time for us to go through all of those things that we've learned. And I believe and have no doubt within me that the sky will not just be the sky won't be the limit for us, but it's just going to be the starting point. All right, so today we're going to be talking about AWS, and I'm sure that majority of us already know what AWS is. For those that do not, for those that have never used AWS before, right? So AWS stands for Amazon Web Services, and is a comprehensive and widely used cloud computing platform that is provided by Amazon. So Amazon is the parent company of AWS, right? So AWS offers so many cloud services, including computing power, storage, databases, and of course, machine learning, AI, analytics, security, and so many other functions, within the Amazon Web Services itself. So by the time you hear cloud, I'm sure that Shane has done justice to the Azure class that we had the last time. By the time you hear cloud, right, one thing that should come to your mind is what? Compute, storage, database, machine learning, security, and all, on a platform, right? On a platform that is not necessarily owned by you, that is not necessarily owned by your organization or an organization. So it's just a platform where you can launch the different variety of services that you have, and on that particular platform, you have the computing power needed to be able to support the applications on your workload. You have the storage, you have the database, you have things around security and what have you. So and of course, many organizations today are migrating their workloads, from the data center, from their physical data centers that they have, to the cloud, based on different reasons. And of course, we all know the reason, such as the cost of maintaining the data center. You have to pay for cooling, you have to pay for power, you have to pay for security, you have to pay for so many things. But right now, organizations are moving their services to the cloud, because all of those things would have been abstracted from you, in that you don't need to worry about the physical security, you don't need to worry about storage, you don't need to worry about maintenance of your different databases and what have you. All that you just need to do is to launch your compute and properly architect how all of these services would communicate with each other. So AWS has over 200 services, right? They have over 200 services, but the popular ones are AWS IAM, which is Identity and Access Management, which we're going to talk about. And of course, we have AWS Lambda, we have DynamoDB, auto scaling, virtual VPC, which is the virtual private cloud. We have IAM, we have S3, like we have so many services, like we have over 200 AWS services. So by the time you are able to log onto your console, which I'm going to show us right now, by the time you're able to launch your console, right? Once you log in, this is the AWS console that you have, and this is the beginning point of anything that you're going to be doing within AWS, right? So how do you get across to how do you log onto AWS? I'm sure most of us know. Let me just open a new incognito and just type AWS console, and of course you can click on this. So if you have an account, you can just sign in. But if you don't have an account, you can create an AWS account over here, which I'm sure that it shouldn't be a big task for us to do. So if you need to sign in, you can either sign in through the root user or the IAM user, which I'm going to talk about right now. So the same thing as well for Azure. If you need to log on to Azure portal, it's still the same way you need to sign into Azure portal. So let's see. So let me see. Okay, so of course, so this is like the Azure portal, where you can manage services on Azure, which is owned by Microsoft. So you can sign in, and this is going to take you to like the sign-in form, for you to be able to sign into your Azure. So the same applies to AWS as well. So by the time you log on to your AWS, the first place you are going to see here is the console, and this is more like the launch pad into your cloud itself. So by the time you click on AWS here, it's going to bring you to the console and click on the services. Right. So these are the different services that we have, and within each service, you have some other services that perform analytics. You have services that performs application integration. You have services, that is, that helps with blockchain networks, business applications. Like we have so many containers as well. We have Elastic Container Registry, Elastic Container Service, and a host of other services. On that database, there are different services as well, media services, a whole lot of services. So these are over 200 services, but the common ones are the Amazon S3, the AWS Identity and Access Management, AWS Lambda, and host of other services. So, all right, so because it's going to be a very, very introductory class, we're going to start with the first service, which is the IAM, Identity and Access Management. Now, how do you access the individual services itself? You can just come to search here and type, let's say I want to access S3 buckets. So you can see, so by the time you type the S3 buckets, you see the service listed here. So the S3 buckets, excuse me. So sorry. So the S3 bucket, of course, is just used for storage and retrieving of data. It's used for data storage, backup, hosting of static websites and what have you. That is just the basic function of an S3 bucket. And that S3 stands for Simple Storage Service. That is why you have 3S, which is what Simple Storage Service. And that was how they were able to get S3 buckets. Another common service that we have is called the EC2 itself. So EC2 provides compute capacity in the cloud. So your server, so the servers that you usually should launch today, right? They are called EC2 on AWS, and they provide compute capacity in the cloud. They are used for what? Hosting applications, running virtual servers, scalable compute workloads, and what have you. The third most common services, the third most common service, we have another one called the RDS. So the RDS is called Relational Database Service, which is used for running and scaling relational databases. And we know the different types of relational databases that we have. We have MySQL, we have PostgreSQL, we have Oracle SQL Server, and host of other services. Now, you don't need to manage any infrastructure as opposed to where you're coming from. Traditionally within your environment, where you have like data center, and then within that data center, you have like a physical server where you need to install your SQL server, be it Microsoft SQL Server, MySQL, and what have you. But here, you don't need to manage your infrastructure, right? So for you to be able to create that kind of service, you need to create the RDS. Another popular service is what we call either Amazon Lambda this way. So you can even see the description: run code without thinking about server. So most of the services that you have on AWS, they're actually targeted at the use case that will help you not to make use of servers at all. They just want you to, launch your applications, and, all of these services would handle the deployment backend itself. Because of course, these services will still be deployed backend, but you don't even need to manage, worry about server, how to provision storage and what have you. You don't need to think about that. And of course, the AWS Lambda is an event-driven. It's actually used for event-driven applications. It's used for microservices architecture, and then automation of tasks, microservices architecture, and then event-driven application itself. So that is where you use Lambda. Then another service, another common service is called the IAM, which I'm going to talk about right now. IAM. So IAM stands for Identity and Access Management. And this is basically used for securing your AWS resources. So things around security, this is a service that you call to, help you with that itself. Then the last common service is called the VPC. Now, the VPC stands for Virtual Private Cloud, right? And it helps you to be able to create your own private network within AWS, which I was going to talk about today. So that is how you are able to access the different services within AWS. So let's talk about the first one, IAM. So what is an IAM? Just like I've said, IAM. So IAM stands for Identity and Access Management, and it's a web service that is provided by AWS to enable you to, secure and control access to your AWS resources. So under IAM, you manage, different resources under IAM. So if I click on IAM here, I am presented with this particular page itself. So this is the, console for identity and access management. Now, under here, these are the different tasks on the left-hand side that I can do under IAM. There's user group, there's users, roles, policies. So very quickly, we're just going to talk about each of them one at a time, right? So, so let's talk about users. So by the time you click on users here, what are users? Okay, let me delete this. Okay, well, I can do this as well. So what are users? Users are identity. So we need to be able to use the correct terms. So by the time you are asked that, what is a group, what is a user, what is a role, what is a policy, what is anything under IAM are called identities. So user is an identity or an entity within your organization who interacts with AWS resources. So if you need someone to be able to interact with like the database I talked about, or your VPC, you will need a user. and this is where you create a user. So let us go ahead and create a user. So whose name can we use? Okay, I think we can use, okay, let's use Patience. So let's create a user called Patience. Let's say Patience dot what, who else is here? Let's use Emmanuel, Patience dot Emmanuel. So let's just assume that this is someone's name, right? So now, by the time you click on create a user, you are greeted with this, then asking you about the user details and all. So just by the time you type in the username here, just click on next. And it's asking you that user that you want to create, you can add the user to a group, you can copy permissions, or you can add attach policies directly, which was going to talk about. So here we're not going to add that user to a group. We just click on next, and we're greeted with the user details. The user details and create the user. So right now we have created patients.emmanuel. So what do we have here? Now, by the time you create a user this way, you are greeted with what we call an ARN. And an ARN is a very, very important information for resources within AWS. And ARN stands for Amazon Resource Name. Amazon Resource Name. And they uniquely identify AWS resources. So you cannot have multiple resources, with the same ARN. So this ARN is a unique identifier, for the different objects that you create within AWS itself, right? Which is very, very important. Now, I have created a user. Right now, I am currently logged in as a root account for DAS Cloud. Now, AWS recommends that you always work in your IAM account and not the root account, because the root account has super privileges. And when it gets compromised, it can be very, very messy, which this is very, very important. This is very, very important. So it is good that you don't work as a root user, because of the super privileges that this has. But it is very, very important that you create an IAM user, which you've done, and then give this IAM user the privileges to do whatever it needs to do, right? So after creating this, we need this user to be able to log in. So let's say we want patients.emmanuel to be able to log in, because right now this user cannot even log on to anything. But we want this user to be able to log on to a console. What can you do? You can come here, right? You can click on permissions, then add permissions, and of course you can add the permissions here, or you go to security credentials as seen here. So by the time you click on security credentials, you can see console sign in. So within this console sign in, there is a link that this user would have to make use of to log in. But before that, we need to enable console access. So this is the console. So we need to enable the console access for this patients.emmanuel. So click on enable console access, right? Enable. And of course, it is asking you that do you want an auto-generated password for this person, or you want to create a custom password, and do you want that user to be able to create a new password at next sign in. Of course, this is best practice, but just keep things simple and click on apply. So by the time you apply this, it is telling you that this is the console sign in that you should give to that user, right? This is the person's username, and this is the console password that we've created. So you can also download the CSV file and give this to the user. So let's log in with this user. So I'm going to copy this, go to a new incognito mode and paste this URL. then come back and copy the username. So I'll just wait for this to sign in. So so there's what we call the account ID, which I'm going to show us now. So the account ID is the unique ID for your AWS account itself, for your AWS account, which I'm going to show you. Right. So the IAM username, you paste the username here. The password, just like we saw here. Where am I coming from? Let me just close this. So the password is what we have here, right? So let's go ahead and log in with the password and sign in. So by the time you sign in, right, this patients.emmanuel has signed in into our account. So let us wait for the sign in to be concluded. Okay, so by the time you sign in, it would want to guide you through the different menus that we have, or what have you. So of course, you can click here, and then you see the name of the user, patients.emmanuel, and of course the other links that is associated with this patient.emmanuel. But right now, this patients.emmanuel does not have any privilege to be able to do anything. For example, let's say an S3. So let's say patients.emmanuel wants to create an S3 bucket. Okay, so let us wait for this to finish. So you can see you don't have permissions to list buckets. So meaning this user by default, it doesn't have permission to do anything. You can see if I want to create buckets, the reason why that button was enabled about a few seconds ago was that this account was still being initialized. But right now, I can't even do it. I can't even do anything. I don't have permission to be able to do anything. So right now, this user can only log in, but she's not able to do anything. Right. That now brings up to the concept of policies. Right? Policies. What is a policy? A policy is, or policies are a set of permissions that define what actions are allowed or denied on AWS access. So we need to create a policy and then attach that policy to this user, because just like I've said, there are a set of permissions that define what actions. An example of an action is to list buckets. That is an action. So you can see what they say here. S3 list all my bucket action. So I need to create a policy that will help me to be able to do this action. But right now, by default, it is denying the list all my bucket action. So we need to create a policy to allow this action to happen. Are you guys with me? Can you guys hear me?
Yes, we're here. Yes, we can.
Loud and clear.
Okay, yeah, good. So I need to create a policy that would enable patients.emmanuel to be able to perform this action itself. So let's go back to the root console. So this is the root console here. I can now come back to policy. So on the left-hand side, just click on policy here. And you have several policies, that have been defined within AWS. But we're going to create our own. So we're going to create a policy here. Now, by the time you want to create a policy, right, you can either use the visual or the JSON representation. But in this course, we're going to make use of JSON. We're going to make use of JSON here. So what do we have here? This is what we call a policy editor, and it's very simple. And for you to be able to sort of, because you can go for you can be invited for an assessment online, and then you're asked to modify a particular policy itself. or you're asked to create a policy. It's very simple. For you to be able to create a policy, just know that the acronym is SEAR, SEAR. So by the time you know this acronym, then you'll be good to go. Just know that there's an S in front of the ear, or you can just name it as SEAR this way. So what does this stand for? The S here stands for seed, right? The E stands for effect, the A stands for action, and the R stands for resource. So these are like the building block of a policy. Remember that a policy, are a set of permissions that define what actions are required, are allowed or denied on AWS resources. So what is a seed, SID? So a seed is just a unique name of this policy. It's just a unique name for this policy. And remember that we want to grant access to patients.manual to be able to, list buckets, create buckets, and, just do virtually everything under S3 only. She's not creating VPCs. She's not creating databases. She just wants to, create an S3 bucket. And that is what we want to do right now. So here we can now say, just give it a unique name, maybe create S3 buckets. Can name it as this way. Okay, someone is asking, sir, can you send to us? I don't understand why you want me to send to you. Would you also call it an authorization policy? Yes, of course you can. You can call it an authorization policy as well. Because of course, this would help you this will grant you authorization to, perform an action within AWS. So the seed is a unique name of the policy, right? The effect, now what does effect stand for? Effect would only contain either allow or deny. If you don't specify anything, it would default to deny. Do you understand? So this policy is an allow policy. Now, the action is another very important thing that you need to understand. Now, what is an action? Follow me. An action element specifies the specific operations that are allowed or denied on the AWS resources. Are you guys with me? It's an element that specifies the specific operations or actions. You know that this is the action. Sorry, let me just go back to this. So consider this is the action, and this is the specific action itself. So this is what we're now going to put inside the action block. This is what we are going to put inside the action block itself. So the action element defines the tasks or the operations that a user, a group, or a role is allowed to perform. So let's go back to our policy. And what is the action here? The action here is, so you can remove this box. Excuse me. Excuse me. So the action here is what? We want to allow S3, or you can even come back here and just copy what you have here. You can copy this action and go back to the policy that I want to create and paste it. Or let's even allow everything under S3. So you can just put an asterisk this way. So by the time you put an asterisk, it means you want to allow a particular user to be able to do everything under S3. That is why I have put an asterisk there. But if you want this user to be able to, list only buckets or list objects in a bucket, then this is what you are going to, add over there. So let's move on. Now, The last one is now what we call a resource. Now, what is a resource? A resource element helps you to define the scope of the permission by identifying the specific AWS resource to which the policy applies to. So right now, we want this to apply to all the resources. So don't worry, by the time we get to role, you're going to further understand what a resource is. But also know that a resource is an element that helps you to define the scope of the permissions by identifying the specific AWS resource. So for now, let us keep things simple and select all the resources. I want to make use of all the resources this way. So we are done here. Remember this SEAR, SEAR, where S stands for what? The seed. E stands for what? Effect. A stands for action, and R stands for resource. Common interview questions. What are name, some building blocks within an AWS IAM policy? So what? SEAR, seed, effect, action, and resource. Okay, so let's go ahead and click on next. So here you can now give it the policy name. Let's say allow, let's say does allow S3 actions. Maybe policy this way. So now so once you've provided the policy name, if you scroll down here, you're going to see that automatically, based on the policy that we have, it has extracted the policy for us, and the service is what? S3, full access, all resources, and of course we have none here. So let us go ahead and create the policy. So after we create that policy, let us look for that policy again, which is this policy that we just created, right? So you can expand the policy to see what we've created here. Create S3 bucket, does, allow, and all. So the next thing is now to assign this policy to this user that we created, to this patient's Emmanuel user. So by the time you click on patient.emmanuel, right, you go to add permissions, right? Then click on add permissions. By the time you click on add permission, you now click on what? Attach policies directly. So we want to attach that policy to this patient.emmanuel. So click on this, then search for that policy that we just created, which is this policy, and then click on next, add permissions. So once this has been done, you can just give this some seconds, maybe like another 30 seconds, and go back to that user and refresh. So you can see that based on that policy now, this user now has access to do anything on that S3. So you can just go ahead to create a bucket, and and of course select everything that you need and what have you. But the bottom line is this user now has access to be able to create this policy, right? So moving on, let's quickly talk about groups. So of course, group is just a container, to be able to collect different users, within an organization. So how do you create a group? You can just click on create group here and give it a group name. Let's say patient.emmanuel is within the DevOps group. So you can create a group here, daas DevOps group this way. And of course, you can add patients.emmanuel. Then the beauty of it again is that you can now add a policy. So instead of attaching a policy directly to patients.emmanuel, you can attach that policy to this group so that everybody within that group, automatically inherits, that policy itself. So here you can search for the daas policy, which is this policy that we created. You can select it and then create a group, and that's that. So that's just the basic thing on that group. Now what we've done is nice by attaching a policy directly to a group, but it's not best practice. So this is what we've done. So let me just delete this. So this is a user. This is a user here. So this is a user that we've created. Now we will need this user to have access to the S3 bucket this way. So let us say this is an S3 bucket. The user needs to have an access to this S3 bucket. What we now did was now to create a policy that say that this policy would have access to these buckets. So after we created that policy, we now attach this policy directly to this user, so that automatically this user can now create, can now administer the buckets that we have here. Now, this is not best practice, because if you have a vendor that needs to work temporarily, on the cloud, right? And let's say, for example, you created that policy, you give it to the vendor is able to log in to do some things. Peradventure, if you should forget that you've given privileges to this particular vendor, the vendor can still be doing some unauthorized tasks, on your AWS space, which is not best practice. So with this, you are not able to expire this particular policy to say that maybe on the 25th of, or maybe after 30 days, I want to be able to expire this policy, or I want to be able to revoke temporary access to this particular vendor, maybe like after some days. Or if this user is caught doing some other things, or if this user attempts to do some other things, for example, by creating an EC2 instance. Yeah, of course, it will not be able to create an EC2 instance, but that audit log would have actually been written somewhere by your CloudWatch. Your CloudWatch, does things around monitoring. So let's say, for example, this user attempts to create an EC2 instance. This has already been logged. There's an action in AWS to say that if this user, is seen doing any other thing aside from, creation of S3 bucket, or creation of objects within the S3 bucket, then immediately revoke this particular access. So, but if you should attach that policy to this user directly, this user is not, like, you won't be able to have all of those granularity. There's no how you can, revoke access and what have you. And that now brings us to the concept of roles, R-O-L-E. Right. So that now brings us to the concept of role, which we are going to discuss right now. So a role is also an identity, right? It's also an identity that you assign policy to. So instead of assigning this policy directly to this user, you are assigning it to a role, and then you are now informing the identity, which is the user, to assume this role. So with this, you can now define all of the granularities that you need, like expiration of accounts. There's something that we'll call federated access. Let me just write it here, federated access. So this federated access that we have here, helps external identity providers like Active Directory, Google, and Facebook to authenticate, against a particular AWS resource. So with that, you don't need to create a policy and then assign that policy directly to, a user, or assign the policy direct to to that particular AWS resource itself. But instead, for the federated access, let's say Google wants to authenticate against your what service now? Maybe your Route 53, which does things around DNS and what have you. What you can do is to create a role, right? And then point that external identity, integrate that external identity to that particular role. And of course, because you've actually created that role, right, you can now do your fine-grained permissions on that role itself. Am I making sense? So a role is an AWS identity, that can help you to create and assign, different permissions to AWS resources. So just like I've said, you can create a role to assist with temporary credentials. You can create a role for federated access. You can create a role for fine-grained permissions. Fine-grained permissions. That is, you want resources to adhere to the principle of least privilege. Just like I said here. For example, if you want this user, the least that this user can do is list or create objects within the S3 bucket. That is the least that you want this user to do. If you should create a policy and assign this policy directly to this user, you've not followed the principle of least privilege. For you to be able to follow this, you need to create a role, because it's this role that can give you that fine access that will enable this user to adhere to the principle of least privilege. Am I making sense? So the process that we're now going to take in this course is that we're going to create a role, and this will be the process. So process number one, we'll create the role. Process number two, we'll assign a policy, not to the user, but to what? To this role that we created in one. Process number three, sorry, let me just delete all of this. So process number three, we would now assign the role to the user, and the process number four would allow the user to assume a role. So these are the processes that we're going to take to create a role. Remember what we want to achieve. We want to achieve federated access. We want to achieve the principle of least privilege. We want to achieve expiration of temporary credentials. And we also want to achieve permission management with the role. Very, very important. So these are what we're going to do. So let us go back now and create that role. So by the time you click on role, you can create role. Please follow me carefully. So now, once you click on create role, it's asking you that select trusted entity, right? Now, the trusted entity that we want to select here is AWS accounts. Because it allows entities in other AWS accounts belonging to you or a third party to perform actions in these accounts. That is why we need to, create a role under the AWS account itself. Is that clear? So, so by the time you click on next, and then if you have another AWS account, you can specify it here. But we're going to be making use of this account. Now, before I go on, I said I was going to show you something on how we're able to on how we got that link that user actually made use of. So let's go back and click on IAM. So after clicking on the IAM, on your right-hand side, you can see the account ID. So you can make use of this account ID if you need patients.emmanuel, to be able to log on to our account, or you can also make use of what we call an account alias, meaning if you don't want to be, if you don't want to always memorize the account ID, you can create the account alias, which is usually unique for different AWS accounts itself. And of course, this is the URL that you give to the users to be able to log on, just like we did previously. So let's come back here. We're trying to create a role. So click on next. Okay. So what role do we want to give to that particular user? Remember that we want what? The full S3, the Amazon S3 full access. So we can either use the one that we created, the policy that we created, or we make use of the policy that comes with AWS. So we've gotten to this point now. So we want to create the role and assign a policy to that role. So remember that the policy would allow users to be able to perform different actions. And what is the action? We want patients.emmanuel to have access to the S3 buckets, which we did initially. But because it's not best practice, that is why we now want to attach this policy to this role that we want to create instead of attaching it directly to the user. So let's search for I think it's S3 full, Amazon S3 full access. So you click on this, you click on next. So let's give it a role name. So let's say S3 full access role. This way. Right. And by the time you scroll down here, there's what we call, okay, so this is still the policy. So you can see the effect is allow. The action is STS assume role. This is the principal, which is AWS, which is what I showed you. You can see here, which is our account 96 is what is here, and then it doesn't have any condition. Now, what is the meaning of STS? What is the meaning of this STS here? So STS stands for Security Token Service. And it's just a web service that enables you to request, temporary least privilege credentials for IAM roles, which of course is what we want to define here. So anytime you see STS here, it means you are trying to give temporary access, limited privileges, access to federated accounts and what have you. So by the time you do that, you click on the create role. So so where is the role that we just created? I think it was this. So by the time you click on this role, you can see the ARN. Remember, I talked about the ARN, and yeah, so this is the ARN for this role that we just created, right? So let's move on. So what is the next thing that we need to do? The next thing that we need to do is to assign the role to the user. And this is a very important step that we need to do. So remember, we've created a role. We've assigned a policy to this role. The next thing is to now assign this role to the user. Assign this role to what? Patients.emmanuel. So what do we need to do? We need to go back to the users. Patient.emmanuel. Let me remove this policy that we attached before now. So I'll just remove the policy and then attach a role to it. Now, how do we attach a role to patients.emmanuel? What do we need to do? We need to go to add permissions here. So instead of adding permission directly, you will now click on create an inline policy here. So click on create an inline policy. Click on JSON. And here we'll now define the policy to allow this user, Patience of Emmanuel, to assume the role. So what is the action? The action here, remember what I told you about action. I said that action specifies the specific operations or actions. Sorry, let me not use the word actions again. It specifies the specific operations that are allowed or denied on an AWS resource. So what is the action that we want to attach to Patience of Emmanuel? The action
S3
is no, the action is not S3. So the action is it needs to assume a role. That is the action. Remember that when we created this initially, we just said that the action is what? S3, where we defined it this way. S3. We define it this way. Remember, let me maximize this a bit. Oops, sorry. This was what we defined when we attached this policy directly to Patience of Emmanuel. But we are not attaching this policy directly to Patience of Emmanuel. Remember where we're coming from here? This is Patience.Emmanuel. Sorry, this is not Patience.Emmanuel, but this is the user. And this is the policy. We attach it directly here. And that was what we defined. That was what they defined here. That's the action. But we are not doing this. This is what we are doing. This is what we've done thus far. We have created the policy and we've attached it to a role. So let me just put the role this way, like a hat. Right now, after this role has been created, we now need this user to assume this role. That is the action. Mr. Man, I need you on action to be able to go and assume this role. So what will now be here is what? STS. Remember I said that whenever you hear STS, you are trying to create a role. So this is going to be STS, assume role. Assume which role? Assume the role of the ARN resource. So we now have to come back here and go to rows. Remember this was the ARN row that we created. Right, so copy the ARN and come back here and paste it here. Am I making sense? Or are you confused? Are there questions?
No.
Do you have any question?
No, sir.
Okay, yeah, good. So now that you've now created a policy to be able to enable this user assume that role, right? You just click on next. The policy name, you can give this S3 full, S3 full access policy. Right, and automatically you can see that the service is what? STS, and I say that STS stands for what? Security token service. And whenever you see security token service, the first thing that should come to your head is that we are creating a role, right? So and then we can create policy, right? Now once that has been done, so it means we have done this. So we have done this. We have assigned the policy to a row. We have assigned the role to the user. And the last thing is now to allow that user to, assume that role itself. So how will the user enter, or how will the user assume this role? So just whenever you hear assume role, it means that this user has been given the hat. So this hat is a role, has been given the hat, but the user now needs to wear the hat. So that is what we want to do now. How will this user wear the hat? How will this user wear the hat? Let us go back to the user, to the user that we created, and ensure that based on that policy that we removed, it doesn't have access to create an S3 bucket again. Let us refresh. So you can see that that policy that we removed now is it has rendered the user, not to be able to list or do anything on the S3 bucket any longer. All right. So how are we going to make use of this user? How do we want to make use of this user to wear this hat? That is where it now comes to assuming the role. And how will this user assume the role? Right. We would have to come to the S3 bucket. That's this role that we created for the user. Right. And then copy this link to switch roles in console. Copy this link. Go back. So you have to give this link to the vendor to say that, Mr. Vendor, this is the link that you are going to make use to log on to our accounts. And once you are done, you don't even need to tell him, because you would have asked him that how many days you want to, work within our cloud space, how many days, then based on that, you would have defined that within the role and give him this link. So you have copied this link. So let us go back to the user. So make sure that the user is signed in, then open another tab and paste this link there. So of course, it's going to tell you that they need to switch the role, blah, blah, blah. Just click on switch role. And automatically, this user would have assumed that role. And how are you going to know? If you go to your topmost link over here, you will see that we have the S3 full access role just for this user. So the user should now go back to an S3. Right. This user should now be able to, create S3 buckets, create objects in an S3. So you can say create. So this user is now able to do whatever it is that he needs to do. If he needs to remove this hat, if he's done and he needs to remove this hat, he just needs to switch back. How is he going to switch back? Let us go back to the user's account. Click on the topmost right-hand corner here, and then you say switch back. So by the time it switches back, switches back, it switches back to what was coming from. So if you should type S3 here again, okay, let me create an S3 bucket. So you can see that user does not have that role any longer, because that user has switched back to where it was coming from. Okay, good. Now that being said, let us move to another AWS resource. We'll talk about EC2 instances. So
please, I have a question, sir.
Okay, please go ahead.
You mentioned when you are assigning a role, like for example, for how many days? How would you do that? Like to do that, like if you want to assign a role to a user for, let me say, 3 days, how can you do that?
Okay, so for that, that would excuse me. So that would be in, okay, so let me just show you. Excuse me, sorry. Okay, so so that's under a particular block that's called condition, right? That's called condition. So remember that when we're creating this, right, there's nothing like condition here. So let me I think I have a demo here. Let me see. Yeah, okay. So this is an example. We talk about the SEAR, right? This is the seed, SEAR. Then there's another thing called condition. So you can add a condition here. Right? And specify the condition this way, if I'm not mistaken. So this is where you now specify the dates, dates greater than what dates. So I think I'm not sure about the syntax, but of course you can specify the AWS let's say current dates, current time rather, and specify, I know this is actually a JSON, then you can specify the date to say that let's say you want this particular policy to how do I put it now? A date greater than, let's say, today's date is what? 2023, 12/23, right? This way. And specify a date less than here. So let me just copy this. Let me just copy this and put it this way. So let's say you need to give that access between 23rd and before Christmas. Let's say I need you to finish everything that you're doing on my cloud before Christmas. This is how you're going to specify it. So a date greater than this, so meaning Saturday, Sunday. Then on Monday, create date. It means you are confining that user to this particular period itself. That is between today and Monday. So by the time it's Monday, you will just see that user will not be able to have access again. Do you understand, Mano?
Yes, thank you very much.
Yeah, okay. Any other question, please, before we move on? Okay, so let's go to AWS resource. Sorry, EC2. So I'm going to be very, very fast. So what is an EC2? EC2 stands for Amazon Elastic Compute Cloud. And they're just virtual servers running on physical hardware in AWS data center. So let us look at a picture of AWS data center. My dream is to enter one of these places someday. So this is, let's say, these are like the servers inside AWS. All of these are physical servers. Again, all of these physical servers you are not the one maintaining all of these physical servers. It's the AWS engineers that would maintain these physical servers just to ensure that there's power, there's cooling, there's high availability, as high as was 99.99999. I think it's 5 nines. Let me just check. AWS SLA. Let me see. Let me just find. I think it's 3 nines or 5 nines. I'm not sure. Okay, well, they have, I think it's 2 nines or 3 nines. So that also tell you that 99.99%, it means that these servers will always be available for life, even if there's a maintenance, right? It can always fail over to another, to another zone itself. So an EC2 instance is created, inside one of these physical hardware that you have here, and then they are usually isolated from each other within a virtualized environment. So within this particular server, right, this server is virtualized, meaning inside this server, inside these physical servers, right, there's what we call a virtualization software that would have been installed on this server. And with that, you are now able to, run multiple instances inside this particular server itself. Do you understand? You are now able to run multiple AWS instances inside this particular server, which is very, very essential. Do you understand? Sorry, who is this that is drawing something on this board? Someone is drawing something on this board. So let me see if I can remove this. So, okay, all right. So, yeah, so that's that. So let's go ahead and create an EC2 instance. We want to create a server inside AWS data center somewhere. So go back. So we are done with IAM here, right? Just come here and type EC2. Very, very simple. So by the time you type EC2 here, you want to create a server, right? You've been tasked by your development team to create a server for them, or to create a dev environment where they can run their development work and all. So this is how you create the server. You create a server by entering EC2. So by the time you click on EC2, you are greeted with this particular console for EC2 resources. So just launch instance this way. Now, by the time you launch your instance, it is asking you for the name of the server. So you can call it maybe daas dev server. Since you want to create it for dev, that dev server, maybe 1. Right now, there's what we call AMI, right? Now, an AMI, you can see here. So please, whenever you are on cloud, always read instructions so that at least you can have an idea of what it is that you are doing. An AMI is a template that contains the software configuration. And what is the software configuration within the context of AWS is the operating system, the application server, and applications required to launch your instance. Now, what AWS has helped you to do is that they've already packaged your OS. They've already packaged your OS, in the form of an AMI. And what that means is that by the time you want to launch a new server, you don't need to start looking for the operating system, now attaching network, giving it a server name or what have you. They've now created an AMI that is customizable to be able to accept the name of the server that you want to give it. That is intelligent enough to accept the network details and host of other customizable things for that particular server to function optimally. So with that, you would have to select the AMI, Amazon Machine Image. So here, you are not selecting the OS, because like I've said, the image or the AMI already contains the OS. It contains the operating system. It contains the application server. It contains the applications needed to run on that server. Do you understand? So, yeah, so that is just what an AMI does. You can also check for more info here. You can see an AMI contains software configuration required to launch your instance. Now, the reason why Amazon has given us an AMI is so that when you launch your instance, it's able to launch in less than a minute. It's able to launch in less than a minute. So what that means is that you are not creating an OS from scratch. because there's a template already that's been given to you by AWS. That template will just start up as if you are starting a Docker service, and that's the power of the cloud. Instead of waiting for Windows Server 2019 to finish booting, by the time it's finished booting, you now have to add it to a domain. You have to patch it, you have to do all of those stuffs. But on cloud, but on AWS, on Azure, you don't need to do all of those things because of the power of an AMI, because that has been baked already to suit your need. So here, I can now select the specific operating system of that AMI. So let's work with Ubuntu, right? Then once you scroll down here, you'll see Amazon machine image, options, where you can now select the different versions that you have. If you want a Ubuntu server with SQL pre-baked, you can select it. If you want a Ubuntu server with PyTorch installed, you select it. So you can see that this AMI is not just an OS, but it contains what? The OS, the application server, and all of the applications needed to be able to run this server. So you can see all of the options that you have. So, but for now, since we are working within the free tier, we'll just select the free tier this way. And you can leave the default. Then the instance type, talks about the resources available to this server in terms of your RAM, your CPU, and what have you. So here, we're going to make use of T2 Micro, which is like the smallest, and it's within the T2 family, and it contains what? One virtual CPU, one gig of memory, and it's, of course, is within the current generation. So if you want a bigger tier, of course, you can go to the C5 large, which is what? 16-bit CPU, 32 gig RAM, or what have you. So there are bigger resources as well that you can select here. You can see the P3 as well. It's 8 CPU, 61 gig memory, what have you. So we'll just stick to our T2 Micro, since it's just a demo. Then there's what we call a key pair. Now, a key pair would enable you to securely connect to your instance. And a key pair usually contains a private key and a public key. That is why it's called a pair, because a pair would contain two things, right? So now, a key pair contains a private key and a public key. Security-wise, it is recommended that whenever you want to log on to your EC2 instance, right, you should always make use of a key pair. Do you understand? You should always make use of a key pair. And we're going to create a new key pair now. So we'll name this, let's say, daas new key pair. And I give it a date, 23/12/23. Oh, today is a very unique day, 23/12/2023. Wow, that's nice. All right, so you leave, just leave the default this way, and then click on create key pair. Now, by the time you click on create key pair, it's going to, download a .pem file. Now, that .pem file that it downloads is called the private key. Am I making sense? Remember that it is a key pair. It means that one pair must be somewhere and the other pair has been given to you. So the pair that has been given to you is the private key that you must have to, keep securely. Like you have to keep it in a very secure place somewhere. Is the private key. While the public key will be baked inside this EC2 instance, so that by the time you connect with that public key, it's going to authenticate against the private key. By the time you connect with that private key, it's going to authenticate with the public key, and you should be good to go. So now that we've downloaded the private key, we'll keep it safe somewhere. Then scroll down to the network settings. We'll still come back to the network setting here. We'll just leave all of this as default. Of course, we would have to allow SSH traffic from anywhere. For example, if I need to allow only SSH traffic from my PC, I have to select my IP here. But since it's just a test case, just select from anywhere and just leave the storage this way and click on launch instance. So why that is happening, you can see that it has successfully launched, right? So click on the instance ID here. Then you can just wait for it to finish launching. So let's give it like maybe like 30 seconds for it to fully launch. So you can see the details, you know, in the TT Micro, public IP, private IP, you know, and what have you. So let's just wait for it to fully launch. Now it has finished launching. So click on the instance ID. Let us see the information that has been provided to us. So there's a public IP address, there's private IP address, there is, you know, DNS name, you know, for the security that we just created, excuse me, we allowed port 22, you know, for what? Inbound, meaning traffic that is coming inside of this server is called the inbound rules, which is port 22. Then by default, it would allow all traffic to go out by default. But by the time it wants to come in, right, by the time that information is coming in, it's called the inbound rule. And this is where you now, you know, say that we want port 22 so that we can log in via SSH. Now, how do we log into this server? Just click on connect here. Then you have like different methods of logging into the server. There's EC2 instant connect. I can even connect it this way. So on the console, I can connect to the server this way. So just wait for it to finish. So you can see I've connected to the server. I can type my Linux commands over here. Clear the screen. New name. So let us see the architecture --architecture. So you can see the architecture of what we just created. Right. We can also check the IP address, which is what 172.31.338. So let us confirm. You can see that is what we have here. And so that's the way. So that's the first way to connect. Another way to connect, which is still the most recommended way to connect, is making use of the SSH clients. So they're not telling you that for you to be able to connect to these clients, these are the different processes that you need to take. You need to locate your private key, which you just downloaded. Then run this command to change the mode for this particular key, right? So by the time you change the mode, using change mode 400, by the time you change the mode, you can now connect to your EC2 instance. So let's do that. So let me copy the key pair. Let me copy it to my Linux server. So I have a Linux server here on my PC. So I need to copy it to my Linux server here. Let me just do an ls. Okay, let me remove the former guy. Okay, and let me copy it to my root directory on the Linux server itself. Sorry, 1 minute. So I need to copy it to my root directory. I just need a Linux environment where I can do a change mode. So please 1 minute. Let me look for the URL for where my root directory is. Okay, I have it here. Okay, so this is my root directory. So I'll copy that certificate that I just downloaded. I'll copy it this way and paste it in my root directory. So by the time I paste it, if I should go back to my Linux and type ls, I can see the key pair that we just downloaded. Now AWS is saying that if you should check the permission right now, which is this guy, it doesn't have, it means your user, your group, and the others. Remember when we're talking about Linux, you know, where we said that the first part here stands for it stands for what? It stands for an identification to tell you if this documents here, sorry, if this file that you have here is either a document or a file. So if the document, you're going to see a D here, but if it's a file, it's going to be blank, which is what you can see here. You can see that the app is the directory that you can see D here. The next three is a read, write, execute for user. The next three, read, write, execute for group. The next three, read, write, execute for what? For others. But because you want to be able to, you know, make the user to at least read this particular file that we just created, right? We have to, you know, we have to create that read privilege for the user by typing change mode 400 and then point to the PEM file that we have here. So by the time you list the permission again, you can see that this now has the what? Let me clear the screen. You can see that this now has the what? The read permission. So with this now, we can now connect to our instance by just copying this and going back to our console and pasting this. So it's saying that do you want to continue connecting? Just click on yes. And there you go. So you are successfully connected into the instance using the private key. So you can check the IP address, which is what we have here. You can also check the architecture just to ensure that that's the right guy. You can also check things around. Sorry. You can also check things around. Sorry, your hosts. You know, you can also check your host name. Sorry, what have you, right? So that's how to be able to create an EC2 instance. Now, if I now need to install packages, you know, dependencies and all. For example, if I need to install, let's say, Apache 2, right? apt get Apache 2. So if I need to install this way, of course, you know, this is a command. But if I don't want to install all of these packages manually, imagine I created 5 EC2 instances. I need to install Docker, Apache 2, I need to install HA proxy and what have you, right? What I have to do is to create the servers individually, one after the other, log in and start installing them manually. That is not best practice. I can create what we call a user data. Now, a user data just contains a how do I put it now? It's just a process of pre-installing packages or software on your EC2 instances during boot up, so that as your instances are booting up, right, all of those things that are contained within your user data, right, would have to be installed during boot up, which is very, very important. So let us see how to do that, right? Let me exit out of here, right, and let's cancel this. So let's stop our instances. I think we are pretty much done with this. So for you to be able to stop your instance, you just come to instance state and terminate the instance this way, terminate, and just allow it to finish. So let us create some predefined user data, so that as my instance is booting up, for example, now the developer has said that on that dev server that you want to create, please ensure that you help us install Apache and install Docker. How do we want to do it? So come to your create instance again. So let's say we want to create the daas dev server 2, right? Select the AMI of course, we'll still make use of the instant type. The key pair would make use of the one that we created, right? I think it's the daas.ng key pair, right? I guess. Let me just find out from here. LS. Okay, daas.ng key pair. Okay, so we'll just leave the default this way. Now, because we want to create an Apache server will definitely listen on port 80 and port 443. So we have to select that it should allow traffic, meaning if you should come to the URL and type, the public IP address of this server, right, and then point to port 80, it should be able to accept that traffic and then point it to the Apache instance running on the server. So that's why we need to accept HTTP and HTTPS traffic. Then we'll leave the configure storage. Then expand these advanced details. By the time you scroll down, you see somewhere that is called the user data. And this is where you have to, state your commands so that once your EC2 instance is booting up, all of those packages can be installed. So I have a sample here, which we can make use of. So this is just going to install Apache 2, while the second one is going to install Docker. So I got this from Docker's official website. So I will just copy all of this. Right now, this is usually a bash script. When your Linux server is coming up. For example, if you want to provision a Windows server and you want to sort of maybe run some scripts, maybe like PowerShell script and all, you have to also define the PowerShell script within your user data. So a user data is not just limited to only Linux servers alone. You can also run it on Windows. So we'll copy this our user data. So we are saying that once the server is coming up, please help us install Apache and also help us install Docker. So let us copy the user data this way and paste it here. Right. So once that's done, so let us launch the instance and wait for it to come up. So just keep refreshing this. So by the time it's up, we'll connect to it. And so by the time it's done, we'll connect to it and check if it has installed our Apache and Docker. So let's keep refreshing this. Okay, so it is up. So click on the instance ID and connect. So I'm going to copy this client again. And because we have our .pem, because we're making use of this private key, and it's still within this same present working directory, which you can see here. Right, so we'll paste it here and press enter. Click on yes. Okay, so now let us check if Apache 2 has been installed. So that will be systemctl status Apache 2. Okay, so let's still give it some time to see. So you can see our Apache 2 is up and running. It started 6 seconds ago. So it means if we should go back to our instance and enter the public IP, enter the public IP this way, we should see the home page of our Apache here. Right, so if you don't see it this way, because by default Apache runs on port 80, but right now it is trying to take us to port 443. So we just have to remove this, remove the HTTPS, and you can see that we are good. So based on that user data that we created, right, we didn't have to install Apache by default. Based on that user data, Apache was what's installed automatically based on the user data that we fed it to it. Okay, so good. Let's also now go and find out if our Docker is running. So system ctl status Docker. Okay, so Docker is not running. Now, how do we troubleshoot to find out that this was what we fed to AWS, and this is correct? This was what we fed to AWS. So why didn't Docker install? Right? Why didn't Docker install? So part of what we can do, let us find out if it's up. So Docker is not up. Let's say docker.service. So why didn't the user data install it? Now, remember that when we're talking about Linux, right, we see that all logs of a particular Linux environment can be seen within what? The var log directory, right? So if you should go to cd var log directory and type an ls, you're going to see a cloud init output. And this is just telling you that this is the log for all user data installation. So let us see, and so let us tail the last 3,000 lines of this particular file to even find out why Docker was not installed. So that would be tail dash the last 3,000 lines. I want to cloud init dash output.log. So let us see. Okay, so let us follow it and see why Docker was not installed. Okay, so let's see. So where did we start from? Okay, so this was where the server was updating. Okay. Okay, so it has installed. So this was where it started. Let me see where it started installing Docker. Okay, so this is where it started. Oh yeah, good. Can anybody point out what the issue was? Just look at maybe the last 1, 2, 3, 4, 5, 6, 7, the last 7 lines. The last 7 lines. Can anybody just point out why the Docker was not installed? Anybody?
I think issue of space. There is no enough memory for Docker dist to be installed.
You tried, but that's not the correct answer. You tried actually, but that's not the correct answer. Just look at the logs. That's why I said that whenever it is that you are troubleshooting, right, don't just assume that, okay, this is what it is. The log is already pointing to where the issue is, right? So look at it critically based on our Linux class. Why didn't Docker installed? Anybody? DevOps engine, DevOps practitioners. Oh yeah, now. Why didn't Docker install? It's here already. Like it failed, right? So it failed here. So why did it fail? Okay, let me say from here down. So the answer is here already. Why did it fail? Look at it critically. Don't worry, you can just give any response. Why did it fail?
Is it because you didn't give it because it asks if you should yes or no, and maybe in the bash script you don't have you don't have this something like this to accept yes or no in the bash script.
Correct. So that's the answer. So you can see that here it was saying that do you want to continue, but it was waiting.
No response.
No response, and then it aborted. So that was why Docker was not installed. So we need to go back to our script because I didn't even because I felt that, oh, this is just a way to install Docker. It's going to install. I didn't even emphasize that it's going to install here. So what you just have to do is just like I passed yes here. So this yes pipe means that whenever the bash script is asking for, do you want to proceed or do you want to do this, the default should be yes. So I need to pass this as well here. I need to pass this as well here. And okay, well, we can just pass it out there because this is at the point of installing Docker. So what will now happen is I'll copy this. Unfortunately, we would have to terminate that our instance again and create it. So so let's go back to our instance. I think this one was the one that was running. Terminate instance, terminate. Okay, so so let us wait for it. So it's shutting down right now. So please, whenever you are troubleshooting, make logs your friend, right? I didn't even know that this is going to fail. I didn't even know. I just felt, okay, we'll just install Docker and move on. So let us launch another instance. We'll call this daas, let's say web Docker server 1. So we'll give it our AMI. We'll still choose the defaults. Our key pair is still this. Allow HTTPS and HTTP. Then advanced details. So we'll copy the right AMI. Copy the right AMI and paste it here. And launch instance. So let's wait for the instance to come up. Okay. So let's refresh. Okay, so while this is refreshing, we'll just log in to confirm if Docker and Apache has been installed. Okay, so it is running now. So let's click on the instance ID, and let us give it some time, because it needs to follow all of those installation method and all. So let us give it maybe like a minute or two, and we'll come back to it. Okay, so do you guys understand? Is that understood? Are we good? So I'm going to log on to it now and just check, and just check if everything is fine. All right, so let's refresh this and connect once more. All right, so copy this, come here and clear it. So we'll log in again. Yes. Okay, so that's clear. And system CTL status Apache 2. So Apache is running. So let's do Docker PS. So you can see that Docker is now installed, but it's telling me permission denied. So let's do sudo su and do a Docker PS. So you can see that Docker is now installed. So you can do a Docker pull nginx this way. So you can see that our user data has been able to install Apache 2 and Docker successfully. So if you do a Docker PS Docker image ls, so you can see the nginx image that we just created. All right, good. So let's move on. So let's move on to AWS global infrastructure, where we just quickly talk about the AWS global infrastructure. And now under the AWS global infrastructure, there's what we call region, there's what we call availability zone, there's what we call local zone, which I'm sure that some of us already know. So but we'll just quickly touch this and then we'll move on. Now, a region is a geographical area within AWS or within Azure or within Google Cloud. A region is a geographical region that contains 3 or more availability zones. So this is a region, which you can see here. So this is a region, right? And it contains what? 3 or more availability zones. What is an availability zone? An availability zone are physically separate and isolated data centers, right? And they contain one or more data centers with direct, low latency, high throughput, and redundant network connections between each other. So a region contains what? Contains what? 3 or more what? Availability zones, right? So this is the 1, is the 2, and this is what? Is the 3. So this is a region. It contains what? 3 or more availability zones, right, in a geographical area. Now, an AZ here contains what? 1 or more data centers. So this is like data center 1, data center 2, like that. And these data centers, right, they are all interconnected with each other. Data center 3, they are all interconnected with each other. So means there's a connection between DC1 to DC2, between DC1 to DC3, between DC3 to DC2, like that. And they are all connected via a low latency. A low latency means that there's no form of sluggishness, or there's no form of latency, there's no form of delay between the data centers, right? There's no form of delay. It has high throughput, and they are redundant, so that even if one data center should go down, right, the workload will still not be affected, because that workload, if the user actually specified high availability, that workload is also replicated in another data center itself. But hardly before you see a data center going down, unless if there's war, maybe there's flood and what have you. So that is why AWS are usually very careful when it comes to creation of data centers. They will just ensure that it is not close to an area that is usually flooded, an area that is usually affected by earthquake and what have you. Now, what are local zones? Local zones, they place compute, they place storage, they place data center and other AWS resources to the end users. So this is an AWS local zone here. So this is more like saying it's a mini data center, right, that is placed very close to the users. So let's say in Nigeria right now, we have Netflix users. Netflix users are only in Lagos. They are only in Lagos. If Netflix comes around to inform AWS that, please, because of the latency issues that Netflix users in Nigeria actually experience, please, can you help us create a local zone so that the users using Netflix are going to have a very nice experience? They can now say, okay, yes, we can do that. Now, where is the highest concentration of Netflix users? They now said, okay, they're in Lagos. Do you now know what AWS will do? Instead of building an entire data center, they'll just build a local zone and place it very close to the Netflix users in Lagos. That is what an AWS local zone is. You understand? It places compute, storage, database, and other AWS services closer to the end users. Any question before we move on? Any question, guys? Okay. Can you hear me?
Yeah, I can hear you.
Okay, good. Yeah, cool. So let's move to VPC, Virtual Private Cloud, right? And that will be where we're going to stop for today. Now, under the VPC itself, right, there is a concept called the IP address scheme itself. Now, what are IP addresses? IP addresses are addresses that computers or resources use to communicate with each other. It's as simple as that. So if I need to reach Bamidele's server somewhere, I'll just ask for the IP address, ping it. Okay, it's reachable. You know, I could also telnet to it, and that's because that is what I can use to locate a particular resource somewhere. Now, an example of an IP address is what? 192.168.0.1. This is a very simple IP address that we have. 192.168.0.1. Now, this is called a decimal notation on AWS or on any cloud platform that you have. So this is called a decimal notation because of these dots here. So this is called a decimal notation. And every part of this particular IP address. Now, I've actually entered IP addresses. I've actually entered IP addresses right now. I'll just sort of explain, the basic things that you need to know about IP addresses. Of course, it goes beyond just, just knowing IP addresses. You need to know the concept of network addresses and then the host addresses itself. Now, this IP address that you can see, right? It's every part of this particular IP address, you can see that it's actually divided into what? It's divided into 4. So this is the first segment. This is the second segment. This is the third segment. Meaning we have 1, 2, 3, 4. Excuse me. Now, each segment is called a binary octet. So this is called a what? A binary octet. BO. This is called a binary octet. This is called a binary octet. And this is called a binary octet. Now, why is it called a binary octet? It just means that for me to get this 192, it means this 192 contains 0 or 1 bits. So this is an octet. So the combination of all of this is called an octet. What makes up these octets are called bits, and bits are either 0 or 1. And how many bits are there in an octet? From the word octet, which is 8. So it means there are what? 8 bits, meaning 1, 2, 3, 4, 5, 6, 7, 8. So this is what makes up 192, right? So this is what makes up 192. The same thing here. 1, 2, 3, 4, 5, 6, 7, 8. This is what makes up 192. The same way. So now the total of the binary values, they all sum up to 255. They all sum up to 255. And then the table for the binary view is usually in this way: 128, 64, 32, 16, 8, 4, 2, 1. So what does this mean? It means if you add, it means if you add 1 plus 1, 2, 2 plus 2, 4, 4 plus 4, 8, 8 plus 8, 16, like that, it will get to 128. Now, based on these binary values, what and what can make up 192? Mathematicians, what plus what will make up 192? Anybody? Remember that this is the octet. It means that what we have here is the representation of what made up 192. So this, like this, was what made up 192. So what and what can we add to get 192?
128 plus 84.
128 plus what?
84.
54.
84.
84. Okay. So it means 128 plus 84 gave us 192. So it means the octet notation will now be what? 1 1 0
0 0
0 0 0 0 0. Do we all understand? So this was what made up. So this was what made up 192. So instead of these dotted stuffs I have here, I can just place it this way. I can just place this way. Do we understand? Or we are confused? Ada, I've not heard your voice today. Are we good? Okay, she's not even on the call. Okay, so now what would make up 168? What would make up 168?
128, 32, and 8. That is 1 0 0 0 1 0 0 0.
1 0 0. Okay, 1 0 1 0 1 0 0. This way, right? So this is going to make up this is what is going to make up 168, like that, and so on and so forth. Right. Now, having known this, right, this will now help us to cross another concept called the network ID and the host ID. So based on this right now, we don't know the subnetting, or we don't have further details of this particular IP. We just know that there's 192.168.0.1. We don't even know what this is actually speaking to. And that is where the concept of the network address and the host address comes into play. Now, let's assume that this particular IP address is the IP address of a particular workstation somewhere. So let us term this as a workstation. So this is like the IP address of this particular workstation, right? 192.168.0.1. This workstation, because it has this particular IP, right? It is part of what we call a network address, because this particular IP was from a pool of addresses, was from a pool of addresses, and that pool of addresses is called the network address itself, because you can only get this particular IP address from a network address, meaning this actually came from a parent. This came from a parent, and the name of that parent is the network ID. So the network address is the portion of the IP address that identifies the specific network to which a device belongs itself. So let's say, for example, now this particular system that we have, this is the IP address. It is possible that it originated from a network of 192.168.0.1 network. So it means that other systems here would now be 192.168.0.2, 192.168.0.3. You can see that the only thing that is changing is the last octet. Now that last octet is now called the host ID, because that is what identifies the specific device, which is this device here. It identifies the specific device within a particular network. So that part that does not change is the network from where this host IP originates from. Now, how do we now differentiate? Because right now, we don't even know. We're just guessing that, okay, maybe the network is 192.168. Maybe the network is even maybe the network is just 192 alone. We don't even know what the network address is. But we know for sure that the host ID is actually 1. And that now brings us to the concept of CIDR. CIDR stands for CIDR. CIDR stands for classless interdomain routing. You will need this very well. Classless interdomain routing, and it's the method that is used in IP addressing to, efficiently allocate and manage internet protocol IP addresses. So anytime you see an IP address that is, let's say, 192.168.0/24 this way, this slash, right? It means this IP address is a CIDR notation. Anytime you see slash in an IP address, it means it's a CIDR notation. And it's telling you something. It is telling you that you are able to now identify the network portion and the host portion from this notation because I have added /24. So how do we now know the network portion and the host portion? Now remember that we say that in an octet, right, there are how many bits? There are 8 bits, right? It means here there are 8 bits here, 8, 8, and 8. So 8 times 3 will give us what? 24. That is why we have this /24. So this /24 means that anywhere you have all of the bits mentioned within the CIDR, this is now called the network portion or the network segment of this particular IP address. Why the other guys here is the host segment. Do you understand? So can we do this together? What if I have, so let me just do this. What if I have a CIDR notation of, anybody can help out, of 16? So which segment is the host segment? Anybody?
The third and the fourth.
The third and the fourth, good. So if I have /8 this way, which segment is the network segment?
The first.
Network segment, the first, good. What if I have 20? Which segment is the network and which segment is the host?
Network is the first, and the host
so
is.
Okay, so let me just write it down. So that means that I have 8 here, right? I have 8 here. Okay. So what will now happen now? Because they are saying that the CIDR is /20. So what will happen here?
For that break.
Okay, so it means we have to segment this into 2, right?
Yeah.
And this is 8, 8, 16, and then we have 4 here. So it means the remaining 4 and 8 here. So it means from here is the what?
The network.
So this is the network, and this is the host. Now, we are able to do this because of the concept of this CIDR. Once you get this concept, and then you see something like 192.168.0.0/27. So in your head, you should be able to know that, okay, this is how I'm going to segment the network. So the network is going to have this number of bits, while the host is going to have this number of bits. Am I making sense? Does it make sense?
Yeah, it is.
Okay. All right. So now based on this explanation that we have now, then we can now move to VPC. So now you remember that when we started our AWS here, right? When we started our AWS, our console, all of these resources are, how do I put it now? You cannot see them as public resources. But because we want to build our own data center, you can see VPC like having your own private data center inside AWS. You want to cage it. And by caging it, you need to provide your own CIDR. By the time you provide your own CIDR, you need to provide the subnets. So it's just like having, this is the AWS data center. You now want to have your own data center because we have services that are publicly accessible. You now want to have your own private data center. Now, for you to have your own private center, you need to start by creating what we call a VPC, which is a virtual private cloud. So it's a logically isolated portion of the AWS cloud within a region. Do you understand? Within a particular region itself. So it means that this is a region. This is a region. Within that particular region, right? You now have your, okay, let me just remove this. Okay, so within that, you now want to have your own VPC, virtual private cloud, inside your region. Right? Inside your VPC, this way, you have already made it private. And of course, we can give this a CIDR of what? 192.168.0.0/16. So what does this mean? It means that the host segment is going to be what? The last two, while the network segment is going to be what? The first two. So this, let me see. Okay, we can give it 10. We can actually give it any address, but let's name this 10.0.0/16. I think that's what we have here. Yeah. So can give you this CIDR. It means the first two are the network addresses. Excuse me. Why the last two are the host addresses? So this can now come here this way, meaning my VPC. This is going to be the IP address of my VPC. Excuse me. So now, this is a region. This is my VPC. Now, within my VPC, right, I now need to create, remember what I talked about, that within region, we can create what? Availability zones. So let me create an availability zone this way. So let's say I want to have two availability zones. Availability zone 1 and availability zone 2 this way. So this is what? AZ1, and this is AZ2 this way. So remember that our availability zone contains what? One or more data centers. Right? It contains what? One or more data centers. So within AZ1, I can now provision my AWS instance here. So let's say that this is my AWS instance, right? I can also call this maybe like the public subnets. Public subnets. And availability zone 2, we have still my EC2 instance, and this is going to be what? The private subnets. Private subnets. Now, follow me. Based on this VPC, how do I now allocate the public subnet address to these two availability zones? You can either calculate it, or you make use of an online tool called site 20, I think site 24/7. So let me get the URL. Okay, yeah, I think I have it here. So you can make use of this. So this is like a subnet calculator for you, instead of cracking your brain and whatever. Now, what do we want to do here? Our VPC is what? 10.0.0/16, meaning the first two is going to be the network. So we'll come here. It's asking for the network address block. So this is going to be what, /16, and then the subnet max is what, /16 that we have here, right? Now, how many subnets do we want to have? Meaning, if we should, how many subnets do we want to have? So right now, we only want to make use of 2. So we can just come here and say we want to have 2 subnets. But guess what? This will be too much. Meaning, within one particular subnet, I will have 32,000 IP addresses. And meanwhile, here I only have one resource. So let's reduce it further and say that anyways, we actually want to have 2 subnets, but we want, maybe for expansion, let's say we want to have 64 subnets, or let's say the number of hosts that we want to have per subnet should not be much. Let's just want 64, right? And of course, we can actually make use of this. We can make use of this, or let's say number of subnets maybe 8,000, meaning we only have eight what is it called now? We have only 8
usable
IPs. Do you understand? So this is a how do I put it now? A site that can help you, subnetting your IP addresses. So let's go back to our /16, and let's say the number of subnets that we have, or sorry, the number of subnets, let's say 64, and that way. Let me see. Oh, no. Let's see. /24. Let me see the one that is. Okay, I think we can make use of this. So it means in one of the subnets, I will have 32 hosts. Does it make, am I making sense, guys? Or it's not confusing? Is it confusing?
No.
Is it confusing? Okay, so let's say that the number of subnets we want to have is 512. The number of hosts is 128, which is not bad. Then it means that here we would have the subnets will now be 10.0.1.0/24. So we can give this to public subnet 1 and give this to .2 public subnet 2. Do we all agree? Do we all agree? Because based on this is what we have now. So I'm saying /24. Let me see. /24. This is what 10.0.1, which is what I have assigned here. So this subnet is going to make use of 10.0.1, while this other one is going to make use of what, 10.0.2, which is what I have here, right? And of course, this is going to be based from the CIDR that we selected. So this is how to, subnet. You can see that there are still so many subnets that can be used, so many subnets. And within each subnet, right, we have 256 hosts, meaning in here, right, we can have 256 instances. That is why carefully, it will be good for you to identify your VPC, because once you create your VPC, you will not be able to, modify it again. You only have to create it once, and then you have to start defining your subnets, right? So this is what I'm going to create in this last section. So this is the AWS. Within AWS, we have VPC. Then we'll create two subnets, public subnet, private subnet, and this is going to be our VPC, virtual private cloud IP address, because this 10.0.0/16, it can accommodate as many IP addresses as possible. Do you understand? So based on that, so let's also go ahead and now create the subnet. So the first thing we have to do is to create the VPC, right? So let's go back to our dashboard and type VPC. So we create the VPC. Very, very easy. Create the VPC. Remember that when you are creating the VPC, right? What you are creating is your private cloud. Do you understand? What you are creating is your private cloud. Are we together?
Yes.
Okay. All right. So what we're creating is a private cloud. So we want to create the VPC only, which we are going to create there. So let's create this daas VPC maybe underscore cloud this way, right? What is the CIDR? 10.0.0.0/ what? 16. Okay. Then I think that is just that for now. Then create the VPC. Now, after creating the VPC, this is the architecture that we're working on, guys, so that you don't. After creating the VPC, there's something that we call the internet gateway. Now, the internet gateway just helps you with routing information to the internet. From the word internet, gateway. A gateway is something that assists you to get somewhere. Internet, gateway. So any guy here that wants to get to the internet, they need to go via the internet gateway, because you are now creating a VPC. Remember, this is a private cloud. So because it's actually within a private cloud, you need for this guy to now go out. It's just like a baby trying to go out of the gate in your compound. Of course, the security will not allow her or allow the baby to go out, because that baby is confined somewhere. So for that baby to be able to go out, it needs to be able to go out via that gate, via the gate that has been provided. And of course, the security personnel will have to allow the baby go out. So that internet gateway is it helps with routing of information to the internet. Now, there's another entity called the route table, right? The route table contains rules or routes that is used to determine where network traffic is directed. So for example, now, if this EC2 instance wants to get to the internet, it doesn't know how to get to the internet. That same baby that wants to get to the gate, that baby needs the set of rules or the set of routes that are needed to be able to get to that gate. So you go and check a particular table somewhere to say that, okay, for me to be able to get to the gate, I have to exit from the kitchen. From the kitchen, I will go downstairs. By the time I get downstairs, I will go straight. So all of those are routes or there are rules for that baby to be able to get to the gate. So the same thing applies here. It's what we call the route table, which is what resources within a VPC makes use of to move from one location to the other. So internet gateway enables resources to get to the internet. Route table contains a set of rules, also known as routes, that are used to determine where network traffic is directed. And of course, the network resources here can now make use of the route table and the internet gateway to get out of the internet. So this is what we're going to create here. So we've created our VPC. Let us go ahead and create our internet gateway. So we'll come back to where's our VPC? Okay, so within the VPC, on your left-hand side, you're going to see internet gateway. So let's create an internet gateway. Very simple. Let's call this let's call it daas internet gateway review this way. So you can tag it, for it's optional. So this just help you to filter and search resources. You can also use it to be able to track cost and what have you. So I'll just go ahead and create the internet gateway. Right. Now, you can see that right now, what is the status of the internet gateway? It is detached. So we need to attach this internet gateway to a VPC. This is what we're going to do now. Let me just close this one that I'm done with so it doesn't confuse us. So, so what do we now need to do? Just click on actions, then attach to VPC. So what is the name of our VPC? The VPC that we just created. So attach internet gateway this way. Okay. So what is the next thing that we need to do? So the next thing that we need to do is we can create the route table, as you can see here, or we can just go ahead and create our public and private subnets. So from this diagram, so we have created, so let me just be marking the one we've created. We've created the VPC, we've created the internet gateway. So let's go ahead and create the public subnet and the private subnet. So how do you create that? You'd on your left hand side, you just click on subnets and create subnet. So by default, these are the subnets that AWS will create for you by default. We're not going to be using any of them. We'll just create our own subnets. So select the VPC. Remember, these are VPC. What is the subnet name? Remember that this is what we want to create, the public subnet. So we'll call this daas public subnets, right? In which availability zone? Remember that this is in an availability zone. In which availability zone? Let's say availability zone 1. So we can call it inside availability zone 1. So here you now select your availability zone. Very important. Right? Very important. So okay, so we have only availability zone 2. So let's just select 2 here and select availability zone 2. Okay, sorry, availability zone 2A. So you can see, so this is an AZ. So this availability zone, it contains one or more data center. So we'll select this way. And what is the CIDR block? What is the CIDR block?
So for the public now.
Yes, 10.0.1.24 public subnets. Public, yeah. So 10.0.0.1. Let me check.
.0.
10.0.1.0.
Slash
1.0/24. So you can see the number of usable IP 256, which is what this guy gave us here. Can you see?
Yeah.
Exactly. So of course we can create a tag and what have you. So let's add the new subnets here. So what is the subnet that I want to add right now? I want to add a private subnet.
Private.
So I will just copy this and private subnets. So this is still going to be within the 2A. I want them to be within the same availability zone, 2A, London, right? So what is the IP address of the second guy?
10.0.0.2.0/24.
Okay. So 4. I think that is that. Then we can create
That's
this.
all. Create.
Yeah. So these are the 2 guys that we have. So we have created VPC, internet gateway, public subnets, and private subnets. So what is remaining is the route table, right? So let's click on route table here and create a route table. So I'm going to create what? We're going to create, so ideally, right, we can create 2 routes table, one for the public subnets and one for the private subnets. So So we can create that. So create route table. So I'm going to create this. So I'm going to call this route table. Let's say tests public. VPC is what? Our cloud VPC. And then create the route table.
Okay,
Now,
sir. If we are having like each of the private and its public subnet, we're having like for the public subnet we have up to 4 public subnet and 4 private subnet. Are we going to use the one route table like for the public for the public subnet?
yes. So you can use one route table. That is why it's called a public subnet. So you can use one route table for the public subnet and use another route table for the private subnet.
Okay, there's
So
no need to create 4 route tables
no,
differently separately and
no. You can actually do that, but of course it's not necessary.
it's
You can
like
actually
for
make use of
resource
one route table.
cut down cost.
Exactly. Yeah. So now, because this is a public route table, and we say that a route table contains rules. So right now, we need to now edit the route or edit the rules of this particular route table since it's a what? A public subnet. So let us edit the rules and let's see what we have here. Right now, it's just telling us that it's just the default route to say that any communication within this 10.0.0/16 should be routable. But remember that we need to go to the internet because this is a public subnet. So we are going to add a route here and say that anything, meaning anything going out to how do I put it? Any traffic going out to 0.0.0.0 out of this particular server, right? Route it to what? Route it to what? Anybody?
Internet gateway.
Do we understand what I'm trying to explain
That's
here,
the
guys?
static IP, right?
Yes, exactly. It should route it to what? The internet gateway. So I'm saying that any traffic that is not 10.0.0/16, right? It should route it to the internet gateway. That is what we want to define here. Because right now, it only matches traffic that are within the 10.0.0 subnets. We are now saying that if there are other traffic that needs to get to the internet, right, route it to the what? Internet gateway. You can now select the internet gateway that we created here and save the changes. Do we understand?
Yeah.
Yes.
So that is how to be able to create the route for this bit here. That is how to be able to create the route for the public subnets. Now, after we've created this, we now need to what? After we've created this, the route table, we now need to associate it with these subnets. So that is what we want to do. That's what we want to do now. So you click on what? Subnet associations, right? And then click on edit subnet associations. What do you want to choose? Public subnets, and then save the association. So it means that right now, the public subnet is going to make use of this route table, and this route table has all the routes and routes that any traffic that is going out to the internet should go via this internet gateway. Are you confused, or you properly understand what we are doing? Do we understand? Do we all understand? Please ask questions. So
Yes, we
do we all
understand.
understand? Okay, good.
Yeah.
Now, what do we need to do? Remember that we said about creating what? 2 route tables. So we've created a route
The
table for
public
this guy. So we need to create
and
a
the
route table for what?
private
This guy.
subnet.
Private subnets. Right. So let's do that. So let's go back to our route table. Create a route table. We are calling this what? Let's see the name that we gave the public subnet. We gave this public. So let's create a route table and call this what? Private. The VPC, we select the VPC this way and create a route table. Right. Do I need, because this is private subnet. Now, what are examples of things that should be within the public subnets? Anyone? What are examples of resources that should be within the public subnets? Anyone? What kind of applications are usually within the public subnets? Hello? Nobody's responding again. Can anybody hear me?
Yeah, we can hear you.
Good. What are examples of applications that are usually within the public subnets?
Web servers.
Web servers. And what? At least by now we should be crossing this zone. This is just like an elementary question. There's web server, there's API, there's load balancer, and what have you. What are examples of resources that should be within the private subnets?
Database
Exactly.
should be within the private subnet.
Yeah.
Good.
Yeah,
so do we now need internet access on the database subnet or on the private subnets?
No,
we don't.
Good. So because we don't need internet access here, it means within the route table, we don't need to edit the rules. We just leave it like this. Because it means if I should add a route here to say that all
somebody
traffic
can reach it.
Exactly. So which is not best practice. So we'll just cancel this way and just leave the private. Exactly. Just leave the private route this way. So we'll just do what? We'll just need to do the subnet association and then edit the subnet association by pointing into what? The private subnet this way and then save the association. Do we understand? Do we understand the scenario right now? So now, so once we've done this, we'll just go ahead and create our EC2 instances and just test what we've done here. Now, what that means is that we can also modify this our diagram to say that if a user, let's say Bamidele now works from home, and Bamidele, sorry, this is not Bamidele, this is just a figure. You know,
of course, I'm fatter than that.
Yeah. So this is just
we understand.
So let's say Bamidele works from home and Bamidele is the database administrator. He manages databases. He works from home. How will Bamidele connect to the databases that sit within these private subnets? Can anybody answer that question?
It's through the IP address.
Through which IP address?
Oh. Through the VPN.
Okay, so through the VPN. So how will this work here? Remember that we're talking about cloud right now. How will this work?
Through the SSH.
Nope. Yes, through SSH, but how will Bamidele, remember that this is a private subnet, how will Bamidele now connect to the database there? Just think now, think, guys. This is not difficult.
So don't forget them.
Routing table.
Is it?
Well, routing table is within the VPC. I'm connecting from outside. Oh yeah, now try, guys. Please, try.
Like
okay, let me give you an idea.
A tunnel.
Okay, good. I can make use of a tunnel. So, but the idea is using a jump server. So where would the jump server sit?
Okay.
Yeah.
At the private subnet.
Are you sure that the jump server is going to sit within the private subnet?
Oh, sorry. Okay, sorry, sir. Public subnet.
Okay, so it's going to sit within the public subnet here. Right? You see within the public subnet here. And then Bamidele can now connect to the public subnet this way. Then from this public subnet here, this EC2 instance, how will this EC2 instance now connect to the private subnet this way? What am I going to do here? Security-wise. Guys, oh yeah, now, this is a very practical question. No?
Sorry, sir, I didn't get the questions.
You have created a jump server within the public subnet here, right? This public subnet, by the time Bamidele connects to this server sitting within the public subnet, how will he now do an SSH to this private subnet, to now, administer his databases and what have you? Can anybody try? Just try.
I think you use the.
That we will need another gateway, NAT gateway, isn't it?
Yes and no. So
because we can't connect to it directly. Okay.
If sorry, please. If they are within the same VPC, I think they can communicate automatically. But if they are within different VPC, we need a VPN, or we either use a VPN or something proxy. I can't remember. Sorry.
So you all are all correct, but let me just explain because of time, right? So Bamidele needs to administer the database here. It cannot come from the internet directly because there is no internet gateway attached to this guy. But we have an internet gateway attached to this public subnet, right? So Bamidele has connected to this VPC here, right? Now this VPC connection, this EC2 connection is called a Bastion host. It's called a Bastion host. A common interview question.
Yes,
Okay,
Bastion. Yeah. So this is called a Bastion host.
You need to explain this one. It's been long. I've been looking for explanation on it.
Yes, sir. You have to explain this.
So this is called a Bastion host, right? Because a Bastion host is like a jump server. Do you understand? A Bastion host is often referred to a jump host. It's a special purpose instance that is securely configured to provide access to a private network from an external network. I'll repeat myself. It's a special purpose instance that is securely configured. Remember the terms I'm using. Securely configured to provide access to a private network, which is this Bamidele's database network here, from an external network. This is the external network here. So Bastion, sorry, I didn't get the pronunciation right. BASTION. So what will now happen is that because of the complexity or because of the sensitivity of this database here, by the time we now want to create this EC2 instance, we'll create this EC2 instance to sit within the private subnet and then tell it that you can only accept SSH connection only from the public subnets here. So that if any other person now wants to, maybe there's a rogue user here that now wants to, connect to this private subnet, it would just bounce the connection. Because the route you are saying is that I want to only accept SSH connection from this Bamidele's Bastion host. Do you understand? From this Bamidele's Bastion host to connect. So let us practicalize all of this thing and then we'll call it a day. So let's go back to our let's go back to our EC2 and create this and see it in action. So we still have one instance running. Right, so I know we're going to stop for today. I will just terminate the instance. So let's launch a new instance. So we're going to call this daas tests public or version public server. Still Ubuntu. Are you guys with me? It's still Ubuntu.
Yes.
Yeah. Then the instance type is still T2 micro. So how will Bamidele log into this version host? Is via what? The SSH key pair. Now, remember that when we started, I said that if you just choose a default, but here you are not choosing any default. You have to edit this network setting. The VPC is what? The one we created. The subnet is what? Public subnet.
Public subnet.
Auto assign public IP. Yes, because we're going to come in from the internet, right? And then you can create a new security group. You can still give it the same name. Let's say, let me say the name of the server that I wanted to create here. Okay.
That's version.
So we can give it daas
Version
security group. Now, SSH 22 is fine. So we can leave this way anywhere, meaning you can actually connect from anywhere. And I think that is that for now. So we have enabled daas and also would click on launch instance. So let's wait for this to finish. So let's refresh and wait for this guy to finish. All right, so now that it's running, we can now connect. Still making use of this guy. So Bamidele is about to connect. Let's clear this. So Bamidele is in his office, or sorry, is at home. He wants to check. Someone just called him now that the database is down. So he's trying to log in via, so he's trying to log on to the partial host. So Bamidele is currently logged in right now to the partial host. So from the partial host, he now needs to log in to his EC2 sitting within the private subnet. So let us create the EC2 instance within the private subnet. So we're going to, so before that, let me copy the name that we use for this guy. And launch the instance. So we'll call this what?
Private.
Private. Right, so we select our Ubuntu. The same key pair. Edit the network setting. VPC, right? Subnet is what?
Private.
Private. We are going to disable public IP because nobody should be able to reach the private subnet. Then we can now call this daas. Can call the security group daas private security group this way. Right, you can still give it the same description. SSH, yes, but not from anywhere. But from where? The SSH should be from where?
I mean, sorry, from
where?
The private public subnet through bash host.
Exactly. So this is now going to be what? We'll now say custom. What is the CIDR for the private subnets?
10.0.2.0/24.
No.
Sorry.
We are saying that it should only accept connection from source. What is the source? Guys, let's not confuse.
That is the static
right
IP now /24.
Yes, 10 dot what? 10.0 dot what? So this is a private subnet that I'm trying to create, and I'm saying that I should accept SSH traffic from where now?
From the public. Right.
From the public subnet, yes. And what is the IP address of the public subnet?
It's 10.0.1.0/24.
Exactly now. So that's what I'm asking from us.
Okay.
So just type it here, 10.0.1.0/24. That is all. That is all you need to do here. And we are done. So it should only accept traffic from here only. Any other guys will be bounced. So launch the instance. So it should only accept SSH via what? Via the private key pair.
Yeah.
So it means that the extra security is that, number one, don't accept traffic from any other person, but accept traffic from where? From the version hosts, and that user must come in via the private
Public
IP,
subnet.
via the public subnet, and it must authenticate against the private key. Am I making sense? Or is it now very confusing? Are we confused?
No, sir.
Good. So now, so let us see what has been created. So this is, let me increase this. So this is the private server. This is the public server. So the private server, let's look at how to connect to it. So you can see that even if I try to connect here, this is not even this thing. This is not a public IP. So let's just even try and even connect to it first and see. Let me exit out. Can you see? I'll be here forever because I don't have access to the internet on that server. I don't have permission to be able to connect to it, because this particular IP address is a private IP. So it will never connect, but it will only connect from where?
The public.
It will only connect from the public
subnet.
Yeah, so let's connect to the public subnet. So connect to the public subnet. Okay. Then from the public subnet. But before we do that, remember that this public subnet here, okay, let's even copy the URL for the private subnet. How to connect to the private subnet. Connect. So I'm copying the URL.
Okay.
This is what is happening.
Yes.
This is what is happening. This is the public subnet, right? I'm able to I'm not able to ping it because, of course, I didn't permit what's it called? I didn't permit ICMP, but I only permitted port 22. So if I try to connect to it, it's saying it, but it's saying that permission denied. That's because I don't have this key pair inside this public subnet. So what I have to do is to exit out and cut this guy here. So I'll copy it. So I'll copy it somewhere. Then I will log in again. So I will log in again. And then create that vpair. Right. So I've created it this way. Yes. Right now, I will need to give it that permission, change mode.
Permission. Yeah.
Plus, okay, sorry, 400.
Okay.
Right. Then I can now connect to it now.
Yes.
Can you see? So
Yeah,
I'm
yeah.
now inside the private subnet, and then Bamidele can now perform whatever it is
This
I want to do. So
database
yes.
work.
So I think for now, although I have some other things I was need to talk about, Lambda functions, RDS, but
Yes.
because of time, we'll stop here for now, and let's just take questions.
So, sir, can we book a day for that based on the Lambda and the database, because we really need it? And most of
Unfortunately,
us,
this is the last class for the boot camp, right? So we might just need to, at least this is just like the basic. Let me just stop the recording.